Our next lesson, you can go ahead and pause the video here and write down your learning goal. We're moving into parts or centers of triangles. So go ahead and pause and write down your learning goal for today. This is also lesson 5-3. Thanks for bearing with me while we're trying to reorganize this geometry stuff. So we're in Unit 5 here. So we're talking about centers of triangles. Here we see we have triangles with a lot of stuff going on. But a circumcenter is a point. Okay, it's important to know that it's not a line, it's not the actual triangle, but it's that point we see in the center of the triangle here. The name actually comes from the word circumscribe. So this triangle, if I draw a circle around it, that is called circumscribing. I'm going to make that a little better. Circumscribing a triangle when I can draw a circle around it. So this point is actually the center of that circle. That's where we get that term from. Okay, so filling in some of these blanks here, the circumcenter is the intersection of all the perpendicular bisectors. So that's what you guys did on Friday, learning what a perpendicular bisector was. Remember, bisect, cut something in half. Perpendicular is that 90 degrees. Okay, so all of these lines where they create a right angle are going to be our perpendicular bisectors, and we see that they intersect in the center at the circumcenter. A lot of new vocab here. So the circumcenter is always equidistant. Think about what that word means. Equidistant means the same distance. From the vertices. Vertices is just plural of vertex. So if I look at the vertices of that triangle, that is point ABC. So they are equal distances here. So if you think about equal distance would be congruent segments. So I'm going to mark 3 congruent segments there. So let's go ahead and name those perpendicular bisectors. I'm going to change colors here. Go for orange for the gators. So I'm just going to highlight, again, you find the perpendicular bisectors by finding those right angles. So if I name this, remember there's segments, so I need how many points? 2 points. So I'm going to start at the circumcenter for all of these. So circumcenter is P, and then I'm just going out to the sides here. So PD, PF, and PE. And I'm going to put my segment symbol there. The circumcenter, again, is a point. I'm going to change colors, and it is point P. We just name it with that capitalized letter. And we have lots of congruent segments here. Let's go ahead and name those 3 that we know by the rule. So equidistant from the vertices or the vertex. 3 vertex. So again, I'm going to start at P. So P to A is going to be congruent to P to B. Is going to be congruent to P to C. So that comes from our rule that they are equidistant from the vertex or the vertices. Then we also see all of these congruent segments here, and think about where we get that information. So I see that the perpendicular bisector is actually splitting each side of my triangle into 2 congruent parts. That comes from the word bisect. I know I'm splitting it in half. So if I go ahead and list out all of those, let me change colors again. B to E, or segment BE, would be congruent to segment EC. Go ahead and pause the video and see if you can name the rest of these. Okay, so go ahead and double check there with my answers, and then we're going to move down to an example. Okay, it tells me that Z is the circumcenter of my triangle TUV. So let's go ahead and mark everything we know here. We know that it's going to be equal distances from my 3 vertices. I went ahead and just highlighted those. So those are the 3 points that make the triangle or form the triangle. So if I trace them all the way to the circumcenter, they're equidistant, which means they are congruent. So I'm going to go ahead and mark those there. We know that one of them is 21, so that means that all of them are going to be 21. Okay, then we have to know if this is a circumcenter, we have perpendicular bisectors. So let's pick out where those are. And I'm going to change colors here. So that has to be the other 3 lines here. If I go ahead and just highlight those. Then think about what I need to add here. If it's perpendicular, that tells me I have 90 degrees. So I'm just going to go ahead and add my boxes in here to say that that is 90 degrees. Okay, we don't know that those are congruent necessarily, but we do know that they're bisecting each side of the triangle, which means what? That means we're splitting them in half. So I'm going to go ahead and mark those. And I'm going to do singles there. Even though we've already used singles, usually what I do is make those ones in the middle just super big. I kind of like exaggerate those so that they stand out differently. Okay, so that's a lot of information going on. So let's go ahead and start talking about how to find or solve for these missing sides. So let's find TU. I'm looking at letter A here. So TU is this whole side of the triangle. We know that this side is 19, so looking at the congruent symbols, that means that this side also has to be what? That also has to be 19. So to find TU, I can add 19 plus 19. I can also multiply 19 by 2. I'm going to do that the correct way, sorry. So 19 times 2 just gives me what? It's 38. So all we did was double that because they were congruent. Let's look at VY. VY. Kind of the most difficult part here is just finding the correct segment. VY is this piece right here. VY. Okay, the only information that I have there is that 34. That's that whole segment. But I know these are each congruent, so think about what I would do there to find that half of the segment. Okay, kind of give you a hint there. We're going to take that 34 and do what with it? We're going to divide it by 2 to get 17. That means each of these lengths are going to be 17. So using the definition of a bisector there. Okay, let's look at UZ. Let's look at UZ. U to Z is that circumcenter, or to the circumcenter, that equidistant point. We've already said that all 3 of those were 21. So that has to be 21 there. And I'm going to pause the video for a second here. Okay, so from this point, we are going to have to use Pythagorean theorem here. So I'm going to go through this slowly, but remember that's just our a squared plus b squared equals c squared. We have to find c by going across from the island or across from the right angle. So we're looking for WV. I'm going to kind of erase or kind of pull out the information that we have. So WV is this line. So I'm just going to look at that triangle right there. I'm going to rewrite it over here. So putting my right angle there, that is going to be my vertex W. I know that center point is here at Z, and then that has to be B. So just kind of like took everything out so it wasn't so hectic over there. So if I look, that slanted line, or my hypotenuse, is going to be the 21. We know that this side, WZ, is 15, and we're looking for, I'm just going to put X there, we're looking for WV. So from here, we just start labeling using our A, B, and C for Pythagorean. So first thing I want to label is my C across from the island. And then it doesn't matter, again, which way we do that here. So I'm just going to do A and B that way. So using Pythagorean, A squared plus B squared equals C squared. I'm going to go ahead and plug in my C first. And then I have 15 squared plus, we can leave that as B or we can leave it as X, doesn't matter. And then go ahead and grab your calculator and let's start solving. Okay, so 21 squared is 441. 15 squared is 225. And we're going to start subtracting here. I get x squared equals 441 minus 225 is 216. And remember that last step, how do I get rid of the square? I square root it. So I'm just going to hit that button, the square root sign, and I get x equals 14 point, I'm just going to round to the nearest tenth, so 14.7. So a lot goes into those, but really not difficult. We should be comfortable with Pythagorean. So I'm going to have you try TV on your own. So find that triangle with TV. Oh, sorry, and we're done with Pythagorean there. If I just look at TV, it's this whole segment over here. We found WV as 14.7, which means this other side also has to be 14.7. So we're just going to add 14.7 plus 14.7 and get 29.4.